Hello everyone. This is a review video for the concept of crystalline and amorphous solids. It covers Learning Target 2.1 and 2.2, which say that you need to be able to describe and diagram the structure of a crystalline and amorphous solid. So basically it comes down to these particles, which we can still use the term particles, but now we also have learned that we're talking about atoms, and then we'll learn a little bit more about molecules in the future as well. So if we take a look, we're going to be talking about crystalline and amorphous solids, and we're going to start with crystalline solids. Crystalline solids are made up of particles that form repeating patterns. The key here is this word, patterns. That is everything that you really need to know if you truly understand what a pattern is. So if we take a look here, we have an every other particle pattern where there is one chlorine followed by a sodium, followed by a chlorine, followed by a sodium, and it repeats up and down and side to side over and over and over again until it makes a big salt crystal. This is what a pattern is. So this is the structure. There has to be a pattern. It does not always have to be exactly one-to-one, but there has to be some sort of pattern. And when we have that, what we get is structures that give very flat surfaces here, like so. These are examples of crystals, and they break off in these flat edges because of the pattern that is inside with those particles that we were just looking at. We also have a diamond as an example of a crystalline solid, probably one of the most famous ones. But let's talk about those particles some more. Because we have particles that are in a pattern, as you can see up here, these are very strong. There is not a lot of space in between them because they're so well organized. That's lends to being very strong materials when the material has a pattern, a repeating pattern. They are also less flexible though. So what happens is when they are pressured or bent, they will break along these straight lines and the whole particle will break off, and that's what gives us those flat edges from the crystals we were just looking at. They also have high melting temperatures and they are more conductive, and we're going to talk about what that means in just a minute. Let's talk about amorphous solids. They're opposite, not in a pattern. And crystalline solids, as you can see, it's just disorder. It's just like a bunch of particles stuffed in together. Yes, they're close together, but there's no pattern. And that's really the big key. And that's what gives a different set of properties as well. If we take a look at those, these are more flexible because there is a little bit more space in between because there's no pattern, and they're less heat conductive. And let's take a look at a diagram that will allow us to see those two properties a little better. So if we talk about the flexibility and the heat conductivity, if we look at a crystalline versus an amorphous, we see that there's a little bit more space in between in the amorphous solid, so that lends for the flexibility. If we try to flex this material, these particles can move into the empty space, and that's what gives the material the ability to flex. Whereas with a crystalline solid, we don't see really any empty space. There's nowhere to go because it's all packed in a pattern as tight as it can be already. Another thing that we see is conductivity. Heat and electricity being able to move through the substance. As you can see with a crystalline, the heat or electricity can go from one atom to the next very quickly, and with an amorphous solid, it would not be able to because it would be moving around, finding a path through, and so not good heat conductivity, good. So good conductor, and this is not good. Those are a few of the properties, and these are the structures of crystalline and amorphous solids. If you need any further help, please seek the assistance of your instructor.